so we're going to continue our video lecture. We had just left off with solving example 1. We'll scroll down and show that again. We started with a system of 3 equations and 3 unknowns, and we used these steps, Gauss-Jordan elimination. We were able to simplify the system to easily obtain the answer. The difficulty with this is it's an awful lot of writing. There's a lot of places to kind of get lost. And so what we'd like to do is we'd like to develop an easier way of solving such a system of equations where we maybe write less and have sort of a systematic way of solving this. And the way we're going to do that is augmented matrices. So with the aid of matrices, which is just the plural of matrix, a matrix is a rectangular array of numbers. We can eliminate writing all those variables at each step, and we're going to save ourselves a lot of work. So, for example, if we start off with our first system, we're going to write this as a matrix simply by writing down the numbers, the coefficients, with a constant. So the first equation would just be 2, 4, 6, 22. The second equation would become the second row, 3, 8, 5, 27. And then the last equation would become -1, 1, 2, 2. And so we have a matrix. I'm going to draw a line to separate off the coefficients of the variables and the constants on the other side. So that line sort of represents the equals sign. And we could label the top of each column if we wanted to X, Y, and Z. So we could see that the position of each number tells you what the coefficient is for that variable. All right, so we've written that system as a matrix. Let's practice writing a matrix as a system. So we'll go backwards. So let's take a look at this one. The first row is 1, 2, 3, 11. So I'll write X, Y, Z. That becomes X, 1X or X plus 2Y plus 3Z equals 11. The second row becomes 0 X's, so I'm not going to write that down. 2Y minus 4Z equals -6. And then the last row becomes the last column, or last equation, 0 X's plus 3Y plus 5Z equals 13. All right, let's try another one. How about this third one, X, Y, Z in front of the columns? That's 1X plus no Y's plus 7Z's equals 17. The second one becomes no X's, a Y minus 2Z equals -3. And the last row, there are no X's and no Y's, but there are 11 Z's equals 22. All right, finally, let's try one more going this way. If we're given a system of equations, we want to write them as a matrix. So X, Y, Z. The first one will be 1X, no Y's, no Z's equals 3. Y equals 1 becomes 0, 1Y, 0, 1. And the last equation becomes 0 X's, 0 Y's, a Z, and a 2. And we'll split that equals off using a bar, and it becomes an augmented matrix. All right, now each one of these matrices was associated with a system of equations from the problem solving in the example we just did. And you'll notice that if we go back to the original system, so this was the original matrix, and what we did as we solved that problem, if we were going to just use matrices, we would end up with this as our final matrix. And notice that this final matrix has some important things that make it very convenient. We've got ones on the main diagonal, okay? And so each row starts with a 1 and then some zeros, or it might start with a 0 and then a 1. The ones kind of go down and to the right. Then there's no numbers above and below those ones other than zeros. And so this is the form that is our goal, because we know that if we can write it in this form, then we've got three very simple equations: x equals 3, y equals 1, z equals 2, and we found our solution. So we're going to call this row reduced form. And so let's write down in words what we just said, okay? Each row starts with a 1 or some zeros and then a 1. All right. What else can we say? The first one in each row is below and to the right of the first one in the row above. And so that talks about what the beginning of each row looks like. It talks about the arrangement of the ones. And we also need to talk about the zeros. All numbers above and below the first one are all zeros. All right, so that's how we would put that in our own words. Let's see how they put it in the book. And this is how they define the row-reduced form of a matrix, right here. Each row, consisting of entirely zeros, lies below all the rows that have some non-zero entries. So a row of all zeros has to go at the bottom. Number 2, the first non-zero entry in each row is a 1, and it's called the leading one. All right. Number 3, in any two successive, that means one after the other, non-zero rows, the leading one in the lower row lies to the right of the leading one in the upper row. And then finally, number 4, if a column in the coefficient matrix contains a leading one, then the other entries in that column are zeros. All right, so we had mentioned 2, 3, and 4. We did not mention number 1 because our reduced matrix did not have a row of all zeros in it. So if we do have a row of all zeros, it has to come at the bottom. All right, so what we're going to do is we're going to use this definition to look at example 3, determine which of the following matrices are in row-reduced form. And if it's not in row-reduced form, state the condition that is violated. So I want you to pause right now, give this a try, and then restart the video to check your answers. All right, so hopefully you did do that, and now let's take a look and see what the answers are to each of these. So we'll start with A, and we want to know, is this in row-reduced form? Well, let's see here. If there was a row of zeros, it has to be at the bottom. Don't have a row of zeros, so that's okay. The first non-zero entry in each row is a 1. Well, there's a 1, there's a 1, there's a 1. We satisfy that one. In any two rows, one after the other, the leading one is in the lower row is to the right of the upper row. So yes, we go down and to the right, down and to the right to get each one. And in the column of a coefficient matrix with the leading 1, like this one right here, everything above and below it is zeros. That's true of every single one of those circled ones. Everything above and below each one of those is 0. So yes, this is row reduced. All right, let's take a look at the B. A row of all zeros has to be at the bottom, and there it is. So that's good. We've got that at the bottom. Now, if we look at the other rows that are left, each row either starts with a 1 or some zeros and then a 1. So that works. That's number 2. In any two rows, one right after the other, we go down and then to the right to get to the next row, or next one. And so that works. And above and below these circled ones, there are only zeros. So yes, this is row reduced. All right, what about C? There's no rows of all zeros, so we're okay there. Each row either starts with a 1 or some zeros and then a 1. Satisfies number 2. In any two rows, one after the other, we have to go down and to the right to get to the next one. Down and to the right. So yes, it really does satisfy 3. It's true they don't go in a diagonal way, down 1 over 1, down 1 over 1. That's all right as long as it's to the right. It may go down 1 over 2. That still works. And then if I look at my circled ones, I notice that the rest of those columns are all zeros. And that is number 4. So yes, this is row reduced. Satisfies all 4 parts. Okay, let's slide this up. Let's take a look at D. All right, there's no row of all zeros. Don't have to worry about that. Each row either starts with a 1 or some zeros and then a 1. Oh, we've got some problems though. If we look at number 3, the 1s do not go down and to the right. So it, let's see, it fails number 3. They are not down and right, the 1s. And it also fails number 4, because if we look at this right here, we've got a leading 1 and the rest is not zeros, okay? Zeros in the column does not satisfy that. So there's 2 problems for that. It is not reduced. All right, what about E? Well, no row of all zeros. Don't have to worry about that. Here's the first one. Here we've got 0, 0, 1. Uh-oh, 0, 0, 2. That's a problem. So the third row does not start with a first non-zero entry, that's 1. So this one fails number 2. Okay, in addition, if I look at that first one, we've got this problem right here. It also fails number 4. Okay, this first one has to have zeros above and below. So this one is not reduced. Finally, let's take a look at number 3. This row starts with the 1, this row starts with the 0, and then a 3. The row of all zeros, that's fine. All right, so this one fails number 2. Okay, number 2 said the first non-zero entry in each non-zero row is 1, the leading one, this one. That 3 should be a 1, and then it would be reduced. So not reduced. All right, so we're going to stop here, and we will pick up from this point in class next time.